Namaste everyone. Welcome to Vidyalakshmi School YouTube channel. Myself Moses, chemistry teacher here. In this video I am going to discuss some of the organic conversions related to amine chapter, especially the exercise number 13.5. Exercise number 13.5. Okay. What are those organic conversions? Let us see now. Okay. We have certain organic conversions where ethanoic acid can be converted into methanamine. The second one is hexane nitrile into 1-aminopentane. Third one, methanol to ethanoic acid. And fourth one, ethanamine into methanamine. Fifth one, ethanoic acid into propanoic acid. Sixth one, methanamine into ethanamine. Seventh one, nitromethane into diethylamine. The eighth one is propanoic acid into ethanoic acid. Okay, all these conversions let us see one by one, and what are the simple methods we can use for the preparation of the respective products from the reactants. Okay, let us see. Let us see the first conversion. Okay, what is the first conversion we have? We have ethanoic acid to methanamine. We have ethanoic acid to methanamine. Okay, now let us take ethanoic acid here. Ethanoic acid means the root word indicates two carbons are there, that is CH3COOH. Okay, this is ethanoic acid. This ethanoic acid should be converted into methanamine. Methanamine means what? Amine group with one carbon, right? That is CH3 and NH2. How can we convert this one? How can we convert this ethanoic acid into methanamine? Okay. Now the changes is the number of carbons are being changed and the mine functional group is also being changed over there, right? When number of carbons are decreasing over there, we have to go with a particular reaction. We will discuss what is that particular reaction also. Okay. Now let us take ethanoic acid first. What is this one? That is CH3COOH. This is ethanoic acid. Okay. I'll write the direct reaction where I'll make the ethanoic acid to react with ammonia. Reaction with ammonia. Okay. In the first step, what happens is that it forms a salt, because ethanoic acid is an acid. Okay. Ammonia is a kind of base. Together it forms ammonium salt. Okay. That is ammonium acetate formation takes place. CH3COO minus and NH4 plus. The first salt formation took place, right? This is ammonium acetate. Ammonium acetate. Okay. This ammonium acetate on heating gives the respective amide, that is CH3 C double bond O NH2. This is amide. Okay, wherever we can see C double bond O group with NH2 group is known as what? Amide. Since two carbons are there, we can call this one as ethanamide. Okay. Next, in the next reaction, this one should be converted into the respective amine. Okay. What is that amine? That is methanamine, right? That is, let me take CH3 NH2. This is methanamine. Okay. What is the change here we can observe? This C double bond O group has been removed from the amide group over there, and it is turned into what? Just amine, right? What is the best named reactions we can use here is that we can go with Hoffman bromamide degradation reaction. Okay. Hoffman bromamide. Okay. Bromine we have to use to the amide over there. Degradation means what? One of the carbon is decreasing over there, right? In presence of base it takes place, that is NaOH. Okay. What happens? This CO group will be removed, that carbonyl group in the amide will be removed, and formation of methanamide takes place. Okay. This is the direct step for the formation of ethanamide over there. Instead of this, we can also take some other conversion also. What we can go with? Let us take some of the halogenating reagent. Okay, let me take SOCl2 also. Okay. Whenever OH group reacts with OH group or COOH group reacts with SOCl2, right, the respective halides will be formed. Since it is acid, carboxylic acid, the acid halide will be formed, that is CH3COCl. Okay. this CH3COCl, this CH3COCl on reaction with NH3, what happens is that this chlorine group will be replaced with NH3 group and formation of amide takes place. Okay, we can go directly by the reaction of acid with ammonia, formation of salt takes place. This salt again on heating gives amide, and amide and Hofmann bromamide degradation reaction, what will we get? Methanamine. Or we can also go like this. What is this one? CH3COCl, that is acid chloride by the reaction of thionyl chloride with acetic acid. Again followed by reaction with ammonia, what will we get? Respective amide. From the amide, this conversion is common, that is Hofmann bromamide degradation reaction. Okay, let me write the name of the reaction here. Okay, the name of this reaction is Hofmann bromamide degradation reaction. Okay, just look at this conversion. Either you can go like this, or you can also go like this. Whatever you feel comfortable, you can go with. Right? Look at the board. Okay. Next, let us go to the next one. Okay. Before that, let us see the conversion. Okay, the same conversion which we have discussed now. Okay, as we have already discussed, it is ethanoic acid on reaction with SOCl2. What will be formed? Ethanyl chloride will be formed. This ethanyl chloride on reaction with NH3, formation of amide takes place. This amide and Hofmann bromamide reaction gives what? Methanamine. Okay, that the conversion which we have used is right. And instead of going with SOCl2, you can also go directly with the ammonia. Formation of amide takes place on heating, followed by Hofmann degradation reaction, bromide degradation reaction. What will we get? The respective products which we need. Okay, let us see the next one. Okay, now let us see the next conversion, that is hexane nitrile into 1-aminopentane. How can you convert hexane nitrile into 1-aminopentane? Okay, let me take the reactant here, that is CH3CH2 taken 4 times and Cl. Okay, why I am taking here is that here 1 carbon is there, here altogether 4 carbons. Okay, 5 carbons, and one more is 6 carbon from the cyanide. Okay, this one should be turned into 1-aminopentane. What is the 1-aminopentane? That is CH3, CH2, 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 CH2 and NH2. Okay, 1-aminopentane. Okay, we have 5 carbons here, and at the first carbon, okay, NH2 group is there. That's what it is named as 1-aminopentane. Now let us see how can we this conversion can be done. Okay, let us take the reactant now. Okay, what is the reactant? That is hexane nitrile, that is CH3 CH2 taken 4 times and cyanide. Okay, now what I would like to do is I'll just do the complete hydrolysis. Okay, H3O plus or acid or base. Okay, complete hydrolysis. What will happen on complete hydrolysis means we will get the respective acid. Cyanides on complete hydrolysis. Okay, let me take complete hydrolysis. What will we get here is that is CH3 CH2 taken 4 times and COOH will get. Okay, now the thing is we have 6 carbons here. In the product, how many carbons should be there? 5 carbons, right? To decrease the number of carbons, right, we have to go with one reaction, that is Hofmann bromamide reaction. Before we go to the reaction, we should get the respective amide, right? What I will do, instead of going with SOCl2 and NH3, I will directly go with NH3. Whenever the respective acids react with ammonia, right, they'll give you respective amides, that is CH3 CH2 taken 4 times C double bond O NH2. This is what? Amide. This one should be converted into the respective 1-aminopentane. Okay, how can we convert this one into 1-aminopentane here now? See here, let me write the 1-aminopentane, that is CH3 CH2 CH2 altogether 4 and CH2 NH2. Here what kind of changes took place? Let us see. Okay, what is the changes? We have altogether 6 carbons are there. Here 5 carbons are there, which means 1 carbon is decreased. Which carbon is decreased means this one. This C double bond O carbon is decreased. Okay, like degradation took place, 1 carbon is less, right? What is the reaction we should use for the decreasing of one carbon? The best reaction is Hofmann bromide reaction, that is Br2 plus NaOH. Okay, as we have already discussed, okay, from the acid we can get amide directly, or we can also go something like this. What is this one? What is this one? We can take acid with SOCl2. What will we get here? That is CH3 CH2 taken 4 times and C double bond O Cl. Acid chloride we will get first, and this one on reaction with NH3 we will get the respective amide which we were discussing. Okay, after getting the amide, the same reaction, Hofmann bromide reaction. This is about second conversion. Okay, either you can go directly or you can also go like this. What? First hydrolysis, carboxylic acid will get. This carboxylic acid on reaction with some halogenating reagent gives what? Acid halide. This acid halide on reaction with NH3 gives what? The respective amide. After getting the amide, the same process we have to go with. Right? Just look at the slide for 1 minute. Okay, let us see the conversion is right or wrong. Okay, now in this one, what do we have? We have hexanitrile is there. Okay, this nitrile on hydrolysis gives what? Acid. This acid on reaction with SOCl2 gives acid chloride. This on reaction with NH3 gives what? Amine. This on Hofmann bromide degradation reaction gives what? The pentane, like amine which we needed. Okay, these are the conversion. Let us go to the next slide. Okay, we have methanol. This methanol should be converted into ethanoic acid. What is that one? Let us see now. First, let us take methanol. What is the methanol formula? That is CH3OH. This methanol should be converted into ethanoic acid. That is CH3COOH. One carbon is extra, right? For this conversion, what kind of reagents we have to use and what are the steps we have to follow? Let us see in this reaction. Okay. Now we have CH3 as OH, that is methyl alcohol or methanol. Let me take the methanol here, that is CH3OH. What I will do is, for better substitution reaction, I will just use phosphorus tribromide or phosphorus trichloride also we can use. Okay, what happens? Nucleophilic substitution reaction takes place. This OH group will be replaced with bromine group. Then what will we get here? That is CH3Br will get. CH3Br will get. Okay. What is the name of this one? That is bromomethane. This one on reaction with KCN or NaCN. Okay, let us take KCN. Okay. Again, nucleophilic substitution reaction takes place. This cyanide will be replacing bromine over there. Nucleophilic substitution reaction takes place. When nucleophilic substitution reaction takes place, what will we get here? That is ethyl nitrile will get. Right? If you can remember the earlier reactions, right? Cyanides on complete hydrolysis. What will we get? Cyanides on complete hydrolysis, we will get the respective acids. Okay, the cyanide group turns into the respective acid. That is CH3 COOH. Okay, CH3COOH. What is this one? This is methanol. What is this one? This is ethanoic acid. This is ethanoic acid. Okay, this is how we can go with the conversions here. What is the difference between this one and this one? Here we have only one carbon, but here how many carbons are there? 2 carbons. To increase the number of carbons, right? In any one of the steps, it's better to go with cyanides. It might be potassium or sodium cyanide. Okay. To get that one, this should be converted into the respective halide. That one makes a substitution easier with the cyanides over there. Followed by hydrolysis, we will get the respective products. Right? Look at the slide for 1 minute and we will go to the next slide. Okay, let us see whether the conversion is right or not. Okay, now what I have used over there, I have used PBr3, right? You can take anything, like you can take PCl3, you can take PCl5 or SOCl2, anything you can use. what we will get? We will get the respective chlorides or bromides. Okay. This one on reaction with alcoholic KCN or NaCN, what will we get? We will get the respective nitriles, right? This respective nitriles on complete hydrolysis gives the respective acids which we were discussing now, okay. Now let us see the next slide. Let us see the next slide. What is this? Okay, what is the conversion here? Ethanamine is there, that is CH3, CH2, NH2. This ethanamine should be converted into methanamine. This one should be converted into methanamine. What is this one? CH3, NH2. Okay. Earlier we have seen some reaction in which one carbon decreased. Some reactions we have seen one carbon is increased. Here also, how many number of carbons we have? We have 2 carbons here. 2 carbons. These 2 carbons are turning it into 1 carbon. Okay. Somewhere in the reaction conversion, Hoffman bromide reaction is involved. Okay. What is that one? Let us see. Okay. Let us see. Take the reactant here. That is CH3, CH2. NH2. Okay, what we have taken? We have taken the reactant here, that is ethanamine. This ethanamine on reaction with, remember this one, NaNO2 plus HCl R. Simply you can directly take HNO2. Okay. Okay, on this reagent, okay, this amine group will be turned into the respective alcohols, that is CH3, CH2 and OH. What is this one? Primary alcohols. Okay. For this primary alcohol should be turned into the respective acids. How can we convert this respective acid actually? Okay. Now alcohols to the acid, right? Let me take the respective acid, that is CH3, COOH. Now alcohols to acid is what? Addition of oxygen takes place. This is an example for oxidation reaction, right? Oxidation means what? We have to use the respective oxidizing agents. Okay. One thing you have to always remember, primary alcohols gives carboxylic acids. Okay. Primary alcohols gives the acid only on majorly with 3 strong oxidizing agents. One is potassium permanganate or potassium dichromate or Jones reagent. Okay, let us take potassium permanganate. Okay, what's the reagent now which we have to use? We can take KMNO4 or you can also take K2Cr2O7 or you can also take acidified chromium trioxide is known as Jones reagent, that is CrO3 plus H2SO4. Okay, this reagent is known as Jones reagent. JONES, Jones reagent. Okay, any one of these 3 reagents, okay, can convert primary alcohols to the respective acids. When this acid reacts with NH3, we have already discussed, right? Whenever the carboxylic acids reacts with NH3, what happens? We will get the respective amides, that is CH3, C double bond O, NH2. Okay, we got amide now. We got what? Amide now. Okay, whenever we have amide and wants to decrease 1 carbon, means which reaction is favorable, which reaction is useful? We can go with Hoffman bromide degradation reaction. Okay, let me take that reaction now. Okay, what are the reagents we have to use? That is Br2 and NaOH. What happens? This carbonyl carbon of amide will be turned into, will be taken off from the substance over there. That is, let me take, okay, that is CH3 NH2. What is this one? This is methanamine, the desired product. Okay, initially we have taken ethanamine. This ethanamine has been turned into what? Methanamine. That's what the conversion, right? Ethanamine into methanamine. Okay, just look at the conversion. Now let us see whether this conversion is right or wrong. Okay, as we have already discussed, okay, ethanamines we have taken first. Ethanamine, this ethanamine on reaction with HNO2. Okay, HNO2. Okay, instead of HNO2 you can also use NaNO2 plus HCl. Okay, gives what? The respective alcohols. As we have already discussed, these alcohols on any oxidizing agent, on oxidation, okay, Cr2O7 actually, K2Cr2O7 we have already used, or you can take Jones reagent, or you can also take KMnO4, okay, gives what? The respective acid. This acid on reaction with what? Ammonia on heating gives what? The respective amides. This on Hoffman bromamide degradation reaction gives what? The methanamine. What we have seen is right. Now let us go to the next conversion. Now let us see the next conversion, that is ethanoic acid into propanoic acid. How can we convert this one? Okay, that is okay, let us take ethanoic acid first, that is CH3COOH. This one should be converted into propanoic acid, which means one carbon is extra, CH3, CH2 and COOH. How can we convert this one? Okay, first let me take the reactant, that is ethanoic acid, CH3COOH. This CH3COOH I am just converting into the respective alcohols. Okay, whenever we have carboxylic acid, it is highly oxidized substance. This one will undergo reduction in presence of what? Strong reducing agent like lithium, aluminum hydride. What will we get now? We will get the respective alcohol, that is 2 carbon alcohol, that is ethanol, CH3CH2OH, CH3CH2OH. This one on reaction with, let me take PBr3 or SOCl2 or PBr5 also you can take. What will we get now? We will get the alkylated substituted product, okay, that is CH3CH2Br. This CH3CH2Br on reaction with, as we have already discussed, here increasing number of carbon is taking place, right? Increasing number of carbons are taking place means cyanides are involved in any one of the steps. Okay, then what we can use here? We can use KCN or NaCN. Let us take KCN. Okay, alcoholic KCN or NaCN. What we can get here? That is CH3 CH2CN. Okay, this CH3 CH2CN on strong hydrolysis or complete hydrolysis. Okay, H3O plus. What will we get? We know that cyanides on complete hydrolysis gives what? The respective acid, that is CH3 CH2 COOH, CH3 CH2 COOH. Okay, what is this one? This is ethanoic acid. What about this one? This is propanoic acid. Okay, whenever we are increasing the number of carbons, right, one thing you have to remember, first one it should be converted into the respective halides, then the cyanides on hydrolysis gives what? The respective acids. Okay, these are the two important steps in this conversions we have to remember. Next, let us see whether the conversion is right or wrong. Okay, as we have already discussed, we have ethanoic acid on reaction with the reducing agent gives the respective alcohol, on reaction with some halogenating reagent gives alkyl halide. This alkyl halide on reaction with alcoholic KCN gives the respective cyanide, on complete hydrolysis gives the acid. The conversion was right. Next, let us see what is the conversion now. Methanamine into ethanamine, that is CH3NH2 to CH3CH2NH2. Here also what is happening? Number of carbons are increasing, right? Number of carbons are increasing means in any one of the steps cyanide is involved. Okay, let us take how can we convert this one. Okay, what is the reactant over there? That is methanamine, that is CH3NH2, CH3NH2. What I'll do, I'll just make this one react with HNO2. What we can get now? That is CH3OH will get. CH3OH will get. This CH3OH on reaction with, let us take any one of the PBr3 or any one of the halogenating reagent. What will we get? CH3Br. This CH3Br on reaction with KCN or NaCN. What will we get? We will get CH3Cn. This CH3Cn on complete hydrolysis, that is H3O plus. What will we get? We will get the respective carboxylic acid, that is CH3COOH. Okay. This one on reaction with NH3 on heating. We have already discussed the carboxylic acids reacts with ammonia followed by heating. Okay, gives what? The respective amides, that is CH3 C double bond O NH2. What do we have? We have amide now. We have amide group, right? This amide group should be converted into amine, that is CH3 CH2 NH2. Okay, what is happening now? Reduction is happening, right? This process is known as what? Reduction, because instead of oxygen, what is coming over there? We are adding hydrogen. Addition of hydrogen is nothing but reduction, right? The best reducing agent we can use for the conversion of amides to amine is lithium aluminum hydride. Okay, LiAlH4. Okay, this is the reagent which we can use for the conversion. Okay, let us see whether this conversion is right or wrong. Okay, what do we have? We have just converted the alcohol. In presence of PBr3, it gives CH3Br. On cyanide reaction gives respective cyanide. Okay, here instead of going through this COOH step, we have gone what? Through we have gone through COOH step. Instead of that, we can directly go here. Okay, this step is extra step. Okay, we need not to consider these two steps here. Okay, you can also go like this, but extra steps are there, or you can directly go like this itself. Okay, we can directly go like this by taking lithium aluminum hydride. Okay, cyanides on reduction gives what? The respective amines. Okay, these are the conversion. Okay, like if you can remember, like this is not at all required. Okay, this is just extra steps. We can directly go cyanides to the respective amines. Okay, next let us go to the next slide. We have next one. Okay, nitromethane into dimethylamine. What is this one? Nitromethane, that is CH3NO2 nitromethane into dimethylamine, that is NH2 methyl groups, right? Methyl group and methyl group. This is the conversion. How can we do this particular conversion? Okay, let us take the reactant now. What is the reactant we have? That is CH3NO2. Okay, since it is amine, let us convert this one into amines. Okay, how can we convert this one? We can convert this one with metal proton reduction, that is SnHCl, tin HCl, or we can also go with FeHCl. Okay, what we will get here now? That is CH3NO2 turns into NH2. NO2 turns into what now? NH2. This NH2 on reaction with chloroform, that is CHCl3 and NaOH. Okay, this reaction is known as carbylamine reaction. Okay, this reaction is for primary amines. Okay, carbylamine reaction. What will we get? We will get isocyanates. That's what this reaction is also known as isocyanate test. Hence, this one on reduction, strong reduction. Okay, we will take lithium aluminum hydride again. What will we get now? We will get the product, that is CH3NH3. Okay, first what we are doing, we are just reducing nitro group to amine group. This amine on carbylamine reaction gives isocyanate. This isocyanate on reduction again gives what? The product which we need, okay, dimethyl amine. Okay, just look at the conversion and we will see whether it is right or wrong. The same thing what we have discussed, okay. NO2 is turning it into amines. Amines and carbylamine reaction gives isocyanate. This is on reduction, lithium aluminum hydride or sodium with sodium proton reduction, okay. Sodium with alcohol, okay, gives what? The respective amine which we need actually, okay. Let us see the last conversion. How can we convert propanoic acid into ethanoic acid, okay. I hope you could do it by your own, by the previous conversions which we have done, okay. Here what is happening? Propanoic acid is turning into ethanoic acid, right, which means 3 carbon carboxylic acid is turning it into 2 carbons, which means 1 carbon is decreasing, means degradation reaction. You can remember the Hoffman bromamide reaction which we have discussed, okay. That is one of the steps involved in the conversion. Let us take, how can we convert this? Let us take propanoic acid, that is CH3, CH2, propanoic acid, right? Propanoic acid, okay, COOH. This one should be converted into ethanoic acid, that is 2 carbon, that is CH3, COOH. How can we convert this one? How can we convert? Okay, let me take this one. What we can take the reactant, that is CH3, CH2, COOH. This one on reaction with NH3. This one on reaction with NH3. What will we get? Whenever ammonia reacts with acid, we will get the respective amine. That is CH3, CH2 and C double bond O, NH2. This is amide group, okay, NH2 group. This amide group on reaction with, okay, we have to decrease 1 carbon now. What is the best reaction? The best reaction is Hoffman bromamide degradation reaction, that is bromine plus NaOH you can use, NaOH. Now what we can do now, that is CH3, CH2, NH2 will be formed. Why? This carbonyl group will be removed by using the reaction called Hoffman bromamide reaction, okay. This one on reaction with HNO2. This one on reaction with what ma? HNO2, or you can also take NaNO2 or KNO2 plus HCl at 0 to 5 degree Celsius, 0 to 5 degree Celsius, okay. What we can get here now? We can get, that is CH3, CH2OH, CH3, CH2OH. Now how can primary alcohol can be converted into the respective acids? Means by using the strong oxidizing agent. What is the strong oxidizing agent? As we have already discussed, we can use the first one KMNO4, or you can use the second one K2Cr2O7, and or else you can also use Jones reagent, that is a combination of CrO3 plus H2SO4. By taking any one of these 3 reagents, okay, these 3 reagents, what we can convert? We can convert the primary alcohols, that is CH3, primary alcohols to the respective acid, okay, COOH. What is this one? This is propanoic acid. This is propanoic acid. This is ethanoic acid. Ethanoic acid, okay. This is the conversion. First what we have done? We have converted acid into the amide, amide into the amine. Amine means we have decreased 1 carbon over there, okay. That's what, it's a degradation reaction, Hoffman bromamide degradation reaction. This is on reaction with HNO2 or NaNO2 HCl at 0 to 5 degree Celsius gives the respective alcohols, means the primary alcohols. Usually primary alcohols on reaction with KMNO4 or K2Cr2O7 or Jones reagent, which is a combination of CrO3 and H2SO4, okay. Strong oxidizing reagents gives what? The respective acid which we are expecting, okay. This is about the all organic conversions. Let us see the conversion is right or wrong, okay. First what has happened? It has converted into the amide to amine by Hoffman bromide degradation reaction. This is on reaction with HNO2 gives alcohol, Okay, this is on reaction with strong oxidizing agent. We have taken K2Cr2O7, right? Or you can take KMnO4, or you can also take Jones reagent. Okay, gives what? The acid which we need. Okay, this is about the conversions as we have already discussed. Okay, as we have already discussed, as we practice, right, all these conversions becomes very easier for us. Okay, just pause the video whenever one conversion is given. Okay, just try by your own, or if you can't see the video and try by your own. Okay, by practicing you can get to know how to convert from the respective reactant to the products. Okay, how many steps are involved, where oxidation is taking place, where reduction is taking place. Oxidation means what could be the oxidizing reagents, reduction means what could be the reducing agent we can use for the conversion. And sometimes, right, like number of carbons are increasing, sometimes our number of carbons are decreasing. Okay, wherever carbons are increased, in those cases, right, we have used cyanides. Wherever carbons are decreased, we have used Hoffman bromide degradation reactions. Okay, these things you have to keep in mind and you have to practice the conversions. Okay, this is about today's video, and further conversions we will discuss in the next class. Thank you for watching.